Good morning. This is your Stats Sensei, Mr. Spensei, and this is paired an exit ticket for the paired T. So, a sociologist was investigating the ages of grandparents of high school students. The sociologist collected data on the ages and years of the students' maternal grandparents by taking a random sample of 10 high school students out of 1,163. Enter the data in L1, L2, and L3 of your calculator and complete the table below. Well, obviously, I don't have this information, but 75 minus 74 is 1. This is 1. This is -5, -10. This is 8. This is -5. This is -8. This is -2. This is 0. This is +4 and +4. Now, you could have just put the information into the calculator, just L1 and L2, and gone to the top of L3 and go blue button 1 minus blue button 2. And there's the values that I just came up with. All right. So it has it in L3. Well, since it's paired, we're assuming that there's no difference. That's our hypothesis, that we have no difference. All right. Does it appear that the grandmother is younger than the grandfather? So this right here is actually an error. This is say mu d is less than 0 because grandmother, GM, they want to know if she's less than, not as old as the grandfather. Or if you weren't sure, give the grandmother an age. Say the grandmother is 75 and the grandfather is 78. Oh, it's less than. We want to see if they're younger. So this should be mu d less than 0. And so we already have that. I'm going to put that right there. All right. So let's go ahead and start getting our information. Now there's two ways to do this. We can go stat calc, one var stats. Make sure the third button, and we have an X bar of -1.3. Standard deviation is 5.7551. And we have a sample size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our sample size is 10. If I'm drawing a picture of this, the claim is that there's no difference, but we want to see if the grandmother is less. So we end up with a -1.3 down here, and that's our X bar, that's our population, our mu D. All right. So T equals X bar D minus mu D SD divided by the square root of N. So in this case, -1.3 minus 0 over 5.7551 divided by the square root of 10. Inference procedure. One sample T. We're running a test for the mean of the differences because we are basically saying, hey, we're going to subtract all, find all these differences, and then we're going to take the average of all those differences. All right, so let's go ahead and do that. Stat test, T test. Mean is 0. Got data in there. There we go. Mean is 0. Second 3, because we're looking for the data in L3. We want less than. And the probability that T is less than -0.7143 equals 0.2465. That's a pretty big p-value. All right. 2,465 is definitely greater than that. So we're going to fail to reject the null. All right. Basically our p-value is too big to reject it because we like the big p's. All right. Next thing says create a 97% interval for the difference in ages, grandmother than grandfather. So the formula x bar d plus or minus t star SD divided by the square root of n. All right. So x bar d, well, we got that from up above. That was negative 1.3. N in this case, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 differences. So 10 minus 1 or 9 is the degrees of freedom. Hold on a second. Sorry about that. I am at school. Standard deviation. Well, the standard deviation of the sample was 5.7551. And we need to calculate T star. So we're going to do an inverse T. We know that. We're good with that by now. And the area, they wanted 97%. So 1 minus 0.97 divided by 2. And the degrees of freedom is 9. So let's go ahead and calculate that. Second vars, inverse T, parenthesis 1 minus 0.97, close parenthesis, divided by 2. Degrees of freedom, 10 minus 1. And we get 2.5738. So when we plug in x bar d, negative 1.3, plus or minus 2.5738 times the standard deviation, 5.7551 over the square root of 10. Drawing a picture. Please remember, hypothesis tests are different than confidence interval. Hypothesis test is centered on mu d. This is going to be centered on x bar d, or the x, which is negative 1.3. And we're going to need a lower and an upper. Oops. Upper. And this area right here needs to be 0.97. This right here is going to be 1.015. And this area right here is 0.015. I'll show you how I got that in just a second. So here's how I got that. 1 minus the 0.97. That gives me 0.03. So my alpha area, the area between the two tails, is 0.03, but I have two of them, so I have to divide that by 2, and that's where the 0.015 comes from. All right, let's calculate that interval. Stat, test, T interval. L3, frequency, just 1. We want a confidence level of 0.97. Oh, I forgot to label this. I forgot to tell you what type of test it is. We only had one sample. You're like, but there were 3 lists, but there's only one sample of differences. All right, there's only one sample of difference. So one sample T interval for the difference, excuse me, for the mean of the differences. Really important because we're taking the average of all the differences. And remember, difference just means subtract. All right, so let's finish up that interval that I interrupted. And there it is. So we expect a grandmother to be almost 6 years younger to almost 3.5 years older. That's where we think the true mean of the differences is. So we tend to think the grandmother's younger than the grandfather, but it's possible that she's older. All right. Although she'll never admit to it. So there's my lower, there's my upper. I appreciate you watching. I sure hope this helps, and I look forward to seeing you on the next one. Thank you.